Well, thank you very much for coming this early in Monday. I'm having a hard time myself coming up earlier today, so I really appreciate that so many of you came today. So hopefully most of you who are here already are using, or well, at least know Jenkins, but just to make sure. So Jenkins is the most adopted open source continuous integration server. And the reason we are in Java 1 is because it's written in Java. And we track about the 47,000 installations worldwide, and then each with a pretty large number of slaves. The project itself is about 7 years old, so we came a long way in terms of functionality. So we put mainly two emphases on the project. One is that the tools like this needs to be easy to install and easy to use, because it is a tool about productivity and making you do more with this. And also, this product, it prides itself in the extensibility. So because there is this incredible diversity in the kind of tools that we are using, for a single tool to support all of these different environments, we need to be able to sort of develop the integration separately without stepping onto each other. So that's what we mean by extensibility. And today we have more than 600 plugins in our update center. So what I wanted to talk about today is when I go see how people are using Jenkins, and I get a reasonable number of opportunities to do it, the first steps of doing it seems to be pretty straightforward and then widely shared in that people have some build of the project that they will put up on Jenkins to be executed frequently, maybe on every commit. And then from the next step is, from there, the next step might be running the test automatically on Jenkins, kind of like how you do the build. And then some of the users would then start running the code analysis related things. These things should give you, or more importantly, give managers some insight about what the status of the project is. But I often see the use of Jenkins kind of stop there, and then people seems to be at a loss of it. And people doesn't seem to realize that there are so much more you can do with Jenkins. So today I wanted to talk about what is it that we wanted? What is it that I think people should be doing? What is it that value that I see in Jenkins that the people should be able to do? So that's, I kind of wanted to build a talk out of it. So when I ask, what's the next step from there? In a single word, I think that would be the workflow. And when I say workflow, I kind of mean the word very loosely. It's sort of, in my mind, it's about creating a whole bunch of Jenkins jobs and then have them work together to do some interesting things. Because most of the actual software development workflow is a lot more complicated than just building the binary out of the source code. There's a whole bunch more involved in actually delivering that source code into the running servers or to the hands of the users. And then part of the reason why I think this is good for Jenkins is one, because they often involve a lot of manual processes. And then that is also partly related to the fact that these things often need to cross team boundaries. So the development team might want to hand off the binary to the QA guys. And where I used to work before, that was done more or less manually, by our sending email with the link to the storage server or something like that. So the Jenkins is actually pretty good at doing these things, automating these things. And also the design of Jenkins is such that it sort of wants you not to put too much stuff into a single job. It's sort of an anti-pattern. And instead, it's easier for many reasons if you have one job that does one thing well and then try to derive values by interconnecting them. And in that way, you get a better usability out of the stuff. So there are a number of, so let's start with something simpler, something simple in terms of the building blocks. There are a number of building blocks available in Jenkins and its plugins that help you with this. So the first easy one, I think, is the parameterized builds. So if you've already used Jenkins, I think you already know that when you configure the job, you're basically telling Jenkins what to do. And the way you can think of, if it was a programming language, you can almost think of it as procedure without any parameter, right? So you tell Jenkins that, well, go check out the source code from these places and then run these shell scripts on those. And when they are over, here is where the test reports are, and then the binary I produced here, so please grab those, and so on and so forth. Now, and then so when you run this procedure over and over, the only thing that's changing is the set of the source code being checked out. Now, but sometimes, especially when we think about job as a building block into the workflow, it is actually very convenient to be able to define some parameters that affects the way the build would run. So, if I were to carry on this, the procedure analogy, that's really like defining a parameter to this function. And then you can see that as a programmer, we can all see the value in being able to do this. So the defining a parameter, the parameterizing build is actually pretty easy. There is this one checkbox that's sort of very interesting looking in the job configuration UI. And then this is telling Jenkins that you could parameterize the job. So if you click the menu button down below, you can add different kinds of parameters. Here I'm adding a string parameter. I'm giving it a name, which is I'm going to use this name to refer to this parameter later. And I'm also typing in a description so that my users can understand what value he's supposed to type in here. And then just to make the life easier, I also have default values in this. But there are a number of parameter types available. So for example, instead of a text box, you can give user a checkbox, or you can ask the user to upload a file, or maybe you can give the user a choice from the drop-down list box. And in some extreme case, for example, we have a parameter that allows you to list subversion tags. So if you wanted to do some release operation on the tags that the developer team provided, then you can very easily do this. So that's the kind of the extensibility that we get out of this. But anyway, so once you define the parameter, the next step is to refer to the parameter values from within the build. So we use the normal variable expansion syntax. And then, so maybe you can use this in places like, let's say, subversion URL to check out the source code from, or maybe it's going to be the affect the branch that you're checking out, or it could affect the parameters that you're passing to the shell script. And these variables are also exposed as environment variables, so that's often another easy way to access these things and then change the way you do the build or run the tests. And yeah, so there are some exceptions to these rules. For example, when you upload a file as a part of the parameter, that's not going to fit into the environment variable. So the way we're going to do it is Jenkins is going to put the file into your workspace so that you can access it later to do stuff. And then so with that change, now when the user wants to do the build, and then when they click the Build Now button, they would come to, instead of build starting right away, the UI would show up and then ask them to type in the values. And in other places where we can kick the build, like in the REST API or the CLI build command, there will be corresponding options to allow people to type in these parameters. So once you have parameterized jobs, another very useful building block is called Parameterize Trigger build. And somewhat confusing, so this name is somewhat confusing in the sense that it was originally developed to do something else, and we kind of extended into doing something else, and we realized that the latter extension really drastically changed the nature of it. But anyway, so what this is capable of is calling other jobs, and in particular waiting for the completion of the result. And obviously, the reason it's called Parameterize Trigger is because if the jobs that you're calling is parameterized, then you can pass in the parameters. So simply put, this allows you to create this subroutine semantics. You can call into another job as if it's a function, and then you can wait for the completion of it. So one of the common useful pattern is that you could have the sequence of jobs sort of executing in turn. So maybe you start with the setup, so you deliver services, deliver binaries to various places. And the second step, you might execute a load test. And then when that's over, you have a tear down step, right, in the third step. Or you can fork over multiple children's concurrently and then wait for them all to end at the same time. So I guess this kind of makes, I think, the Jenkins Turing complete, right? Because it's a lambda calculus, right? So you can basically do anything with these things, except it doesn't really. There are a number of other common enough primitives that justify their own idioms. So I wanted to talk about some of those. So the one such common idiom that you often see in Jenkins is this ability to more or less do the same thing with slightly different variations. So maybe, it is very common in C++ projects that they need to be, cross-compile into all kinds of different target platforms. So, and that's one of these things, right? So it's basically running the same build, but on different platforms. Or maybe you are testing a Java web app with Selenium through the browsers, in which case, you're basically running the same test, but with different browser, possibly on different machines and different operating systems. So the generalization of this is that when we think of it, it's like you got a number of for loops that the variables going over a range of actual values. So maybe it's a browser going over Internet Explorer, Firefox, and so on. And then maybe you can have arbitrary number of the nested loops, and then you do something that is basically here executing Jenkins job. So this is a common enough idiom that we have a dedicated feature called multi-configuration project, and I often call it the matrix project. So the way you define this is we call individual for loop an axis. So for every for loop, so for every for loop, you define one axis, and then you can define the types of the axis and the actual values. So the most common one would be the generic axis that says, where the person defining the job would specify the string values, and then whatever that means, Jenkins doesn't really care, and then pass it on to the build. But there are also other kinds of axes that's a lot more semantically tied to the way Jenkins behaves. So for example, you could have the slave axis, which says, they execute this job on these machines. You can also have a JDK axis, which allows you to say, well, run this thing on multiple versions of JDK. So before I started, instead of talking too much on the slide, let me just show this to you. So here's, well, let's see. So I created a matrix job, which you can do from here, a new job, to the multi-configuration project. And in the UI, in the configuration page, rather, there is this section that defines the axis. So I define three kinds of axes. The one is, so let's pretend that I'm doing some kind of testing. So I'm going to test my web app with the three different backends, and then on the three different versions of JDKs, because sometimes the XML parsers do behave funny depending on the versions, and maybe something else. This like a two different architecture of the CPUs. So let me cut down some of these guys. And then here, instead of doing the actual build, to make things fast enough, I'm going to just sleep for 3 seconds, and then declare the test be done. So I'm using this. Notice that I'm using variable references here that's referring to the actual values of the parameter. So this, I have now 3 axes, so 3 by 3 by 2, so that makes it 18 different combination. And when I execute this guy, you'll see that in the queue, there's a whole bunch of stuff that's not queued up, and then they are executing in turn, and eventually they'll be all over, and then we get the results. So naturally, in this case, we expect them all to succeed. All right, a few more to go, I think. OK, now it's all done. So we can go look at the individual results. So for example, the one that I'm right now looking at is the 32-bit Java 5 with MySQL. So sure enough, you look at how the variables have been expanded, you see the value that you expect. Maybe do I need to make this bigger? Can people in the back see it? Kind of OK. Yeah, so that's the basics. Now, when you start doing this, it's kind of easy to get carried over and carried away and then start defining a large matrix. So the 18, if you have enough computers to throw at the program, that's good. But the 18 combinations are still pretty large number, especially if each one takes, say, 30 minutes to run. So one of the things that the Jenkins does is they provide you a means to filter down the things that you can execute. So in the axis configuration, you can define this combination filter. So the one way to take, so there's a help that explains what you can do here with all the sample syntax and whatnot. But what I wanted to show here is, let's say if we wanted to cut down the number of executions to half, I could use this magic variable called index, and I took the modulo 2 to drill it down to half. And then so what the Jenkins to do is, you notice that there's like a very semi-grayed out blue and then real blue, right? So what it's doing is, this time around, it's only executing these, the one in this real blue. So the Jenkins had kind of figured out which combination can be removed without removing the test coverage. So if you look at the individual axes, you see that they almost always have even coverage. Because if it wasn't smart enough, if it ends up removing all the 32-bit test and then only leave the 64-bit test, it's still 50% of the combination, but that's useless. So the Jenkins does some arithmetic internally to get this right. Another common thing you can do is to run a few things first before fan out and execute all kinds of stuff. So, oops, not sequentially. So sometimes it happens that someone make a very silly mistake that make the entire test fail everywhere. And then that's a bit silly because, each of these executions is costing some CPU cycles. So what we could say is to declare this, the touchstone build, which basically says, let's try these guys first. And when only after verifying that they work, we're going to run the whole combination. So, so if we schedule this, and then if I'm quick enough in mouse operation, you see that the MySQL is building first, because that's what's declared as the touchstone. And then only after that's successful, it start executing the rest. And if they fail, then the other guys won't be even executed, and the build be declared a failure. So that's sort of the simpler, I guess, the quick introduction of this matrix build feature. It's been around for some time, but it's not as often used as I thought it should be. So that's one. Now, so I was talking about some of the common idioms that that justifies having better support. And another common idiom in this choreography is the act of joining. So imagine you have a number of jobs that's triggering each other. So let's say maybe you had some like a build here, and then after that you got the test execution and the code quality analysis at the same time. And then once both are done, you can tell them to wait for both of these. And then after that is done, you could maybe execute the report job. So this kind of thing is common enough that you have a join plugin. Now, as we'll see later in today, once you start doing more complex choreography, trying to sort of fit your workflow into a number of primitive idioms that we discussed thus far is a bit painful. But if what you're doing is simple enough that you only need to use this to get it done, these are still very useful tools because it's pretty simple to understand. Now, so when you start using multiple jobs and then have them work together, one of the very useful things you want to do is to be able to copy binaries from one build to another. So let's say you got one job that produces a build, the binary, and that compiles and packages up the jar file and stuff like that. And then let's say you have another job that executes the test, right? So because these teams, these often fall on to the different, they fall on to the different set of teams. So it makes sense to have them in two jobs. And then so when you have set up like that, what you want to be able to do, what you should be doing is to be able to copy the files from the build that has completed into the test that's being executing. That's currently executing, that is. So the plugin that does this is called the copy artifact plugin. So you can, by using a various criteria, you could specify where to copy bits from, and then you could also control where the bits will appear. The files that were copied will appear in your workspace so that you can use them in your test execution. So in my previous life, I've used this a lot because we had this ant-based build script, which had every jar files in the library folder. So this was very useful in getting the newer version of the libraries that we depend on, overwrite the checked out copy, and then run the test to verify that this newer version of the library still works with us, and so on. So this is a basic building block of the the interacting jobs. So the thing that makes this interesting, and then I touched on about this little in previous slide when I said various criteria, is that when we think about copying files from one of the builds, I mean, there are all kinds of builds going on. I mean, so you might have, so it's almost like these binaries are version controlled, right? You have you had this build 10 that had certain set of changes, and the next build contains more changes. So you see this, it's almost like, just like the source code is version controlled, you can see that the artifacts in Jenkins build records is like a binary being version controlled. Now, so when you use the copy artifact plugin or some of the other plugins, the way you specify which one of these 5 guys you want to pick up the build from is by using something like label. Like you could imagine that, let's say, build 14 was the last stable build, meaning the build has a blue ball. Or there's other kinds of labels, like people could manually mark the build as important by preventing it from getting garbage collected. And then you get the lock icon in the build history, and then that's called last saved build. So sometimes people use that to indicate like a quality signal. So if some developers would know that this is a good quality build, they would mark that. And then that's basically telling the other guys, the other teams, that this is the build that they want to be picking up, not the random last successful build, which may or may not be a good quality. So this ability to attach kind of labels to these numbers, because the numbers by themselves doesn't really mean much. This ability to attach stuff is even more useful when they have the semantics that make sense to you, as opposed to somehow something that's baked into Jenkins, like last saved build. So again, going back to this example of having the QA team and having a separate QA team and developers, there's this informal notion of signing off the binary from the development team to the testing team, right? So that's a kind of label that you can attach to a build. So because if the developers think that the build 12 is what the QA guys should be using, it'd be very handy if you have a label that designates that kind of thing. And then maybe if you can have another label that says, this is a binary that's deployed to production, that's also useful, because when the bug reports come from production, you can tell that what this is about. I mean, exactly what changes it contained and what not. Now, so this is further more useful if you can actually automate the attachment of this kind of label into the builds. So let's say, again, back to the signed off to QA level. So let's say the development team has come up with like 2 jobs, the developer unit test and then maybe find bugs execution. And then if we could say, if both of these guys have passed, then the build gets this signed off to QA label automatically. In that way, you don't have to manually maintain this label of figuring out which build is supposed to be currently handed off to the QA, but you could entirely automate this. So that's what we do in the promoted builds plugin, which the reason it's called promotion is, I guess that's the sort of the jargon that we used in Sun, and I actually don't know why, but I guess the build is, so in that environment, I believe the build was produced like more or less regularly, like every night. And then after the QA team has tested and signed off to it, those previous build is sort of given a higher quality label, like a beta or the alpha or something like that. So this act of making it more visible is, I guess, is called promotion. So when you automate this, you specify the promotion criteria, meaning how you'd what's necessary, which jobs need to pass for the binary for the build to be promoted, and you could also control what happens after promotion. You could specify Jenkins that it has to do certain things after the promotion happens. And so the reason I like this is that this label is really a nice handoff point between teams. But if you think about how different teams work together, right? So the QA team doesn't really actually care how the development team came to declare that this particular build is ready for the handoff. Right? It's sort of, they have a trust between them that anything that's sort of handed off as this ready for QA consumption, the developer team must have done some reasonable groundwork to make sure that it is the case. And then so later, if the development team had decided, for example, in the early example, that they wanted to add another set of test execution to the mix, then the QA team really wouldn't care about this. So by having, when both teams automate stuff on Jenkins, having these two teams not depending each other's job configuration is a good thing. And then that's what this promoted build plugin provides. So I'm clearly going a bit slower than I wanted, so I'm going to run this a bit quickly. So here, let's say we have this CLI job, which is, let's pretend that this is building every time a new commit happens. And then I'm configuring a promotion here. So this is a promoted when. So that's the entry point into this promotion subsystem. And I'm creating one promotion process named handed off to QA. And then that happens when the developer test had successfully passed. So then, well, I didn't think it, and I'm just creating a bogus jar file, and then I'm archiving this file and then fingerprinting it. It will come back to fingerprint later, but that's basically what it does. Oh, and then after the build is done, I'm going to execute the test. And my test to simulate the realistic test, I'm making it succeed and fail in 50-50 chance by using a little bit of Groovy script. So I have to try a bit of that. But here, before I get into executing the test, I'm using this copy artifact plugin to grab the last successful build, because this is the file that I want to test. Right? And then I'm also recording the fingerprint of the file that's being tested. So going back to the CI, so I pretend that someone put the commit by manually clicking the build now button. So the build 15 should happen. And then now that's executing the test. OK, so that succeeded. So this build 15 was tested by tester D, and then that succeeded. So if you go back to the page, you see this star icon indicating that the promotion had happened. Now, sometimes I should get unlucky, and then the test would fail, in which case I wouldn't really get anything. OK, well, I guess that succeeded too. So let me try one more. The problem with random numbers is that it almost seems to have the life of its own. It's succeeding again. Come on. I know you can do it. Yes, so now it fails, so I don't get the promotion. So as a QA, so let's pretend that I'm now a QA team. So what I want to do is I have a job that executes a more expensive QA test, and then I only want to deal with the binary that's handed off to QA. So this is a job that the QA guys control, and I have a trigger that says this job is supposed to run every time a new promotion happens in the CI job. And then in the actual build, I am first copying off the same a.jar, but not from the last successful build, but I'm copying it from the last promoted build that satisfies this criteria. So in this way, the QA team will not be bothered by whatever successful job, but it only deals with the handed off builds. So if you look at the timestamp, I guess we had a number of successes here today, because I guess earlier we had promotions. So that's how how these whole things are put together. So again, the point that I wanted to show is that the development team doesn't really care how other teams are consuming the binaries. All it's doing is that they're giving certain stamp of approval to certain builds that qualifies certain criteria. So this demo that I showed kind of depends on the copy artifact plugin, which doesn't really work well for Maven or Ivy that wants to download binaries from the repository, right? So that's where the Maven repository plugin comes in. And what it does is it exposes the virtual Maven repository from every build in Jenkins. So because after all, the Maven repository is just HTTP server responding to certain inbound requests that follows some structures. So it's relatively easy for Jenkins to fake a real Maven server, but without having the real storage in it. And not only can it serve artifacts of the build that's produced, it could also sort of show you all the dependency that was used in that build. So it creates a single virtual repository that contains every dependency that this particular build has been produced, which makes it very convenient to run the test. So you could say if this test execution uses this particular last successful Jenkins build, CI build, as a Maven repository, and then there, if you go to the wiki site, you'll see how you can create a POM that's just that. Then the whole scheme could be made to work with Maven reasonably well. Now, so that's about I think that's well. So that's about half the puzzle. The other half is that okay, I'm sorry. So let me try again. So far we proved that you can do interesting choreography between jobs, but the other part of the important challenge is to actually make the data more visible to your users. Because if you look at how we've configured stuff, yes, if you see the configuration screen, you kind of get the sense of what's going on. But if people just come to the UI, they only see like related neighbor jobs, and they don't. It's very difficult to get the whole picture of what's going on. So often you end up having, just a build engineer knowing the entire picture, and everyone else is kind of clueless, which is kind of good for job security, but it's really not good for the teams. So there's a number of plugins in this space. The one that I wanted to show you first is this Dependency Graph Viewer plugin. So what it does is actually, I can show you live here, is that it understands the relationships between different jobs and then they plot that in a graph. Okay, so what it's doing is because the CI job was configured. CI job. Oh, all right, maybe I shouldn't press this button. So the CI job is supposed to triggering this guy, so you get the black line, and then this thin blue line indicates the artifacts being copied. So you see the relationships between who's consuming what outputs and who's triggering what the other ones. And so that gives you some good insights into what's going on. And this is available also per job, so per view. So if you create some views, you get a smaller subset of it, which is a bit more comprehensible. I wanted to also make this extensible so that the other plugins could add interesting graphs, but that's to be done later. Now, another very useful visualization tool is called the Build Pipeline plugin. And so it sort of brings in different aspects into different dimensions into how you look at that. So if you go back to, so this is a visualization of, so let me make the font bigger. This is a visualization of what we were just doing in the CI and the dev test. So in the configuration, I was telling this plugin that go figure out the pipeline that starts from the CI job, and then it was smart enough to recognize that another job was hooked downstream, and it kind of supports the parallel execution and stuff like that, which is nice. But so what this emphasizes is that there is certain context that carries from the CI build to the test execution, right? So the way you should read about it, the way you should read this picture is, every box like that. Oof, yeah, I shouldn't touch this. Every box here is sort of represents a change. So if you're a developer in the team, you're committing some changes, and then that would show up here, and then it's going to test it by one guy, and then it's going to test it by another. So as an individual engineer working in the team, you actually don't care about, you care more about these relationships as opposed to these relationships. Right? So that's why this emphasizes this direction. So if we start the build, which I guess more realistically would happen by someone kicking it, and then this have finished the CI job, and then it should be executing the test. But, so I wanted to show the failure so that you can see the retry. But of course, I'm still subject to the randomness. I guess in a way I'm lucky, but in a way I'm not lucky because I'm not having builds fail. I wish I'm this lucky in the actual production test code. But, okay. Let me try a few more. And if this doesn't fail, I'll just give up. Okay, good. And then so if it fails, for example, I could just rerun this portion, and then that means just it will, re-execute the test against the build 22 of the CI job, and then it will update its status. So this has been used very successfully by a number of people, and it's one of the plugins that's highly recommended. Okay, so the fingerprint. Now, I briefly touched on this earlier in the demo, but this is yet another angle to look at the data. I mean, it's a bit of a stretch to call it the visualization because that's the actual sort of 3D output is somewhat limited, but it's very interesting. So the way you think of fingerprint is like the life log for a blob. When I say blob, it's things like file, jar file, or whatever thing that you care about. Normally, it's attached to like a binary that you want to track. So I suspect many of you have been traveling to here. And now if you think about, so I tried to draw some analogy between the air travel and Jenkins. And so in the airline, I mean, in the air travel, you have a number of things in pieces in the workflow, like the airline check-in counters and then the TSA security points and the immigration officers and so on. So these things, it's kind of like a Jenkins job in a way that they have a set process of what needs to be done and then repeat this thing over and over against different travelers. And then they put together this in interesting ways. So depending on certain airport, right? I mean, I guess most of the US airports will do things in this order, but sometimes there's extra security checkpoint after you go through the immigration, like if you're flying to Israel and so on. So you have a workflow that combines these building blocks into pieces, and then people are supposed to follow this, which is not unlike our binaries being born in the build job and they go through the test, and then maybe it goes through the find bugs and so on and so forth. So if you look at the build history of a single job, you see like a build 12, build 13, build 14, and that's like individual traveler going through the same checkpoint. So you get to see some interesting things like the statistically speaking, how much builds are passing and whatnot. But so in this analogy, the way you think of the fingerprint is like if you think of a single traveler, like me going through all these processes, and then the fingerprint sort of keeps track of what that binary has gone through. When did he go through the airport? When did it go through the airport check-in? When did it go through the TSA? Did he have a pat-down? Did he go through the immigration? Which passport he had, and stuff like that. And so in context of CI, what it does is, well, what changes did this binary have? What was the set of tests that was executed against it? When did it happen? Who started it? And stuff like that. Did it fail? Did it manually restart? So on and so forth. So you get a lot accurate sort of audit trail to the given binary, which is very useful when actually binaries blows up in production. And so it's kind of like a terrorist bombing the airplane, and if he wants to the government wants to figure out where he came from and how did he manage to go through the security. So we provide that kind of the auditability, the forensic analysis trail when things go bad. So the actual mechanism of this is, say, the MD5 checksum. So every time the Jenkins was told to record a fingerprint, it checks the MD5. I mean, it grabs the MD5 checksum, and then record the build that has seen that file against it. So if we notice that the same file has appeared between the build 15 and build 13, if they have the exact same MD5 checksums, they are obviously the same file. And then so that's how we can tell the relationships. And what's interesting about this, and the reason this is useful, is it doesn't really care if or how these two jobs are related. It doesn't have to be. And then so, maybe these files have been copied through the copy artifact plugin. Maybe these files have been uploaded to external repository manager and then showed up later. It doesn't really care. But the big brother, that is Jenkins, is always watching where the files are going. So yeah, I guess I talked about why this is useful, that it provides you the tracking down, the audit trail. In production, it often happens that there's a small shared components between different teams that's gradually consumed into the bigger product. But because the integration between these teams should run slowly, by the time your component is used by this Uber product XYZ, it could be running like a couple of versions behind, or like the one that's produced a year behind. So as a maintainer of this component, when the production team discovers a bug, you're not entirely, without this accurate audit trail, you can't be really sure what binary has been used, or if the fix has been already committed or something like that. So with fingerprints, for example, you can record it against the builds, the binaries that's going through the system. You can, for example, come to this project relationship let's see, project relationships UI, and then you can sort of have these jobs appear side by side. So this is, I created this upfront so that some of these are more meaningful. So here, for example, you can see that, oh, I think I wasn't supposed to press this. So some of this is what I wanted to show you some here is that so the build one, for example, looks good because it's got blue. But if you compare this, if you contrast this with what have happened in the test cycle, you see that this was actually bad, that the test have failed. Now, and then that looks like it was fixed. Well, we can also tell that the build number 2 wasn't used anywhere, so this probably was ignored. But the other build 3 have kind of brought the test back into good shape. But similarly here, if you look at the build 11, looks like the test 11 had failed, so maybe this actually was a bad build. But then you notice that the test guides have re-executed the test, and then that was OK. So you can tell that this doesn't sound like a code problem, but it's more like the test environment issue or the hiccup or some sort. So by bringing those multiple projects side by side, you get a lot more insight into what has happened as opposed to compared to when you're looking at the individual things. So that's why I think this is a part of the visualization. So far we kind of looked at the aggregation result, which is what the visualization was all about. But the next step I wanted to touch on is how you can define workflow in a single place. That is, so far all this configuration was spread into individual jobs. And in certain situations that is useful if these jobs belong to different people, like the QA team owning their set of jobs against the developer team owning their set of jobs. This separation, I think, is actually a feature, not a bug. But if the dev team needs to manage like a dozen jobs that's interrelated, but these things are spread apart, it kind of makes it hard to see them. So this is another area where there's a lot of activity going on right now. And then one plugin that I wanted to highlight was the build flow plugin. So the Jenkins people and Groovy people are good friends. So naturally, we wanted to come with Groovy DSL for executing the builds. So the reason it's called DSL is it's because it provides a high-level primitives for Jenkins-related things. So you see that the build is called like a function. What it's doing is it's executing the build, wait for its completion, and then have the result assigned to B. So that, for example, if you wanted to look at the result, and then depending on it, if you wanted to do different things, you can. You also notice that there's a guard rescue block, which is kind of like a try-catch, except try-catch is a reserved word, so we couldn't assign different semantics to it. So we had to come up with our own. But so that's a convenient way to execute the teardown, because you want to make sure that the teardown will happen regardless of the actual test success or failure. You can also have like things like parallel that executes multiple steps in parallel. And then, so these are all the DSL constructs, but on top of that, this is a Groovy, so you can define arbitrary abstractions that you want. If you wanted to loop through some stuff, if you wanted to access some external data, define functions so that you could call them, you can do all kinds of things with it. So, what you can do with this is almost unparalleled. And the other nice thing about this is that it also comes with a good visualization. So here, I have this build flow job type. And then so the real meat of this is in this, so that here's my DSL. So let's see. So if my Groovy foo is still correct, what this is doing is, actually, let me put the author of this to honor him. So I'm looping through this list of 4 things and then executing the say hello build by passing name as a parameter. Okay, so this would be a sequential execution, and sure enough, if you run the build, oops, okay, that wasn't good. Looks like I guess my Groovy was not as good as I thought. Oh, I see. So missing the close parentheses. So I guess note to myself, we need to add the syntax validation. But you see that it executed these 4 guys in sequence, and then I guess you already seen it, but it also shows you what has happened. And if they are running in parallel, they will correctly do it. So lots of hats off to the Nicolas who made it, who is actually already here today. Another plugin in this space that I wanted to show that's also very interesting to me is the Jenko Plugin. So what this does is it actually embeds the full-blown BPMN workflow engine into Jenkins and execute it. So the BPMN is a standard, so there's a lot of tools that allows you to create these things. And then what this guy made it possible was to define some of the workflow steps as the Jenkins task. So when I say Jenkins task here, that means executing job and wait for its completions. And this being like the full-blown workflow engine, you have all kinds of constructs that you can imagine for this sort of stuff. To begin with, you have this fork and join stack, but you can have a timeout, you could have external events, you could have like a sub-workflow, more than you probably want to know. But it's it really is capable of dealing with the quote-unquote real-world complexity. And so I don't think I have time to actually demo this, but so it comes with the Eclipse plugin. So if you install this plugin, you'll see an update center on Jenkins. You'll see the Eclipse update center on Jenkins. And if you add this guy to your Eclipse, you get the nice GUI editor. The workflow is available in the Git repository that's exposed from Jenkins. So Jenkins itself is a Git server, and then you can check out the workflow as a Git repository from Jenkins, make a local edit by using the Eclipse IDE. Actually, let me just show you the IDE part, which is really nifty. Come on. Here. So you see that there's an IDE editor that allows you to do stuff like drag and drop to create things. And then you could sort of change them together. It's kind of fun to play with these diagrams for a while. And then you can commit the change, and if you push it to Jenkins, and these definitions will be loaded up to the system for executions. So it supports the whole workflow like that. And then you can do other common tasks like sending out the emails and wait for human approvals and whatever have you. So now we looked at the defining choreography in one place. But I think the another next step is to sort of, so we had these job definitions defined individually, and then we are talking about aggregating their relationships into one place. But you could actually also put really everything, including the individual job definitions, into one place. So I wanted to sort of touch that a little. And then, so this is also another new plugin. So as you can, as you can see, there's lots of these plugins that I'm showing today is relatively new. So this is sort of showing the degree of high interest among Jenkins users and developers to make these kind of things easier, which I think is really exciting. But what this plugin does anyway is to create a DSL. Yet again, the Groovy DSL. Groovy people, are you here? See? So what we are doing is that you can execute the DSL that creates a new job in Jenkins. So one of the common requests in Jenkins is that when the people added a new branch to the repository, you wanted to create a new jobs for this branch, right? Without the developer worrying about manually creating it. So scripts like this would do that. You can go to this API endpoint to list up the branches. And for each branch, it creates a job. And the only variation here is that it's passing in the branch name. So the branch name? So I think I got a typo here. But so I was checking out the branch of, it should be just B, I think. Anyway, so I'm passing the branch name, and it's creating a new Maven job. And if there's already existing jobs, so you'll simply update the definition of it. You can also use this to make a small adjustments to all the existing jobs. So it doesn't, instead of defining every job in DSL, you might want to just hand code one template job manually. And then by using this using command, you could load it up as a basis. And then you make the minor tweak to where you need to change it. So this would be a lot easier if you are not very comfortable creating using DSL without help of IDE. And then you could also, there are some gimmicks that allows people to go down to a lower level. If you're a seasoned Jenkins admin, you probably already have touched the Jenkins plugin in XML, you could do those things. And then the neat thing about it is this evaluation of these scripts can be packaged as a Jenkins job itself. So let's say in this early example of looking at the branches and then figuring out when to create the jobs, you can set this up as a separate job that gets executed whenever the commit happens, for example. In this way, as soon as someone creates the new repository, you can check out the build right away. So the other one, I guess, is it's a bit more crude than the earlier plugin, but there's a Jenkins has a CLI job, the CLI interface that you can access through SSH. And then, for example, you can get job, meaning grab the definition of job in XML, and a little bit of a CD command that can replace whatever you want to do. And then you use the update job command to send back the new definition to the server. So you can with a little bit of scripting ability, on your side, like a shell script or Perl, you can very easily do lots of useful stuff with this. Again, it's a bit crude, but often it works very well. And then yet another thing is another approach to this problem is the templates plugin that we developed. And then this is what we put in the Jenkins Enterprise, like Cloudbees. And it's kind of shares the same trait with Job DSL, the idea being that you want to define job once and then use slight variation of this in number of places in kind of like a cookie cutter form. And then you also want to be able to update the definition once and then have the change reflected everywhere. Where it differs from Job DSL plugin is that it allows you to define templates in GUI, not in the Groovy. So that's I think that's both blessing and curse in some way. And it also allows the individual users to type in the actual differences, the UI, in the form and so on, to fill in the blanks, so to speak, as opposed to like Job DSL, where everything is generated from these single program executions. So to wrap this up, there are lots of useful building blocks, some very simple and long-running, to the emerging one that can handle lots of complexity going on in Jenkins. And then so these things that allow you to automate kind of interaction between different teams and different jobs, and in doing so, you can free up a lot more work and then offload that into Jenkins. And I think the other important point is that the amount of new development in this space indicates that a lot of Jenkins users are actively seeking this kind of thing, which I think further validates the reason I'm talking about this here today. It's not just me speaking that this is a good idea, but it's actually many users and developers trying to do this. So with this, hopefully you try some of these and you will be able to take your automation to the next level. So that's it of my talk, I believe. So thank you very much. And if you have any questions, I'll be happy to answer.